All right, folks, let's talk about powers of complex numbers. Let us consider what we mean when we write z to the w, where z and w are both complex. Now remember, complex numbers are any numbers of the form a plus bi, right? So 12 is a complex number, and 3i is a complex number, and 4 minus radical 2i is a complex number. They're all complex numbers. 7 is a complex number. So let's talk about what we mean when we write z to the w. When we write z to the w, what we mean is we mean e to the w times log z. And you should pause the video at this point, because if you see this, you see pretty much everything. Why is this an acceptable definition for our purposes? Why does this jive with with properties of exponents we already know? Why does that hold? Right? 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 Okay. So let's use it. Let's use it. Let's find I to the I, and let's find 1 minus I to the 4i. So just to be clear, at this point in our study, we have dispensed completely with the idea that we're writing I copies of I and multiplying them all together. We have dispensed with this notion entirely. We have grown past it. We have matured far beyond what that understanding of exponents allowed us to do. We are in some whole other intellectual plane. But we are going to continue to use the idea that z to the w is e to the w times the log of z, and we're going to use that. I'll color code here for safety's sake. This is e to the I times the log of I, where this I is red and this I is blue. Okay? Now, how do we do that? Well, we figured out how to do the log of I in another screencast. The log of I is I theta, where theta could have been pi over 2 or 5 pi over 2 or 9 pi over 2, right? Where theta is pi over 2 or 5 pi over 2 or 9 pi over 2 and so on. What is this? Well, I squared is still -1. And so I to the I is e to the negative theta, where theta is one of these numbers. Any of those numbers. Similarly, 1 minus I to the 4i, that's e to the 4i times the log of 1 minus I. Well, how do we find the log of 1 minus I? Well, we figure out how far 1 minus I is from the origin. There's 1 minus I. Its distance from the origin is radical 2 plus I theta, where theta is, well, this appears to be 7 pi over 4, or we could add another 2 pi, or so on. So how does this all simplify? Well, we can say that 4i log 2, that's log radical 2, that's probably fine. And then 4I times I theta, the I squareds are -1, and we get this. And that is an acceptable way to write this. Fair? Fair. Okay, that's probably enough for now, isn't it? I don't need to do more examples, do I? I don't. Thanks for watching. We'll catch you soon.